All right, so our next speaker is Jeremy Duncan from Tachyon Dynamics. Jeremy's spoken at our conference several times and always is a very technical and very interesting presentation. And today I think will also be an interesting piece here for us. Jeremy spent more than 15 years working on enterprise IT, focusing on next generation technology deployments. As you heard, Jeremy's been doing lots of things with the federal government and such over the last several years, and so definitely has a very wide perspective on a number of these different topics. Jeremy spent 11 years in the Marine Corps, deploying to Iraq twice, so we thank him for his service and in his time over there. Anyway, so I'd like to introduce Jeremy and wish him well on this one. Thanks.
There we go. All right. So thank you. So my name is Jeremy Duncan. I'm going to be talking to you about network functions virtualization with VMware's NSX. A lot of discussions in the last few years, especially when it comes to NFV and SDN, have kind of revolved around the OpenStack. So I kind of wanted to give a different perspective of how some of the other vendors, especially one of the big players in the enterprise environment, is especially from the federal side, DoD side, a lot of reliance on VMware. So I kind of wanted to give kind of like an overview of how IPv6 is really working on that. So really how NSX pertains to NFV, kind of giving a brief overview on that one, how NSX works, its IPv6 capabilities and limitations, and there are a lot of limitations, and I'll go into that in a little bit here. How to deploy IPv6 on NSX using NSX, and then we're going to have a nice little live demo. So Ed, I need you to make a sacrifice to the demo gods before we go on here. So, all right. So bottom line up front, right, is NSX for IPv6 is not ready for production. So just right along the lines with OpenStack and has some of the issues right there. So if you were going to say, I'm going to use IPv6 in my production network functions virtualization environment, it's really not there yet. And I'm going to talk about why. Now, does it work? Absolutely, it works. And we'll get around all the workarounds you can do to make it work. But it's just not ready for production yet. Now, what is NSX, right? So if you were looking at years before the acquisition from VMware, NSX actually created a lot of components that did a lot of the network functions virtualization. So it's their answer to NFV. It came from that acquisition from NSX. We'll talk about some of the things they did wrong, which are very interesting, and how the interesting things that Chip talked about when he talked about Neutron and some of the IPv4 only thinking that happened was the same kind of IPv4 only thinking that was happening with NSX. So basically what it provides is distributed switching, logical routing, firewalling, logical load balancing, VXLAN tunneling, and those tunneling interfaces, tunneling services over VPN. So it's like I said, very comparable to OpenStack's Neutron and how it's built. But it's a lot easier from the perspective if you were an administrator from the enterprise standpoint to be able to do the push and click and buttons and things like that. So what does it look like, right? So we have basically our NFV manager. That's basically this virtual machine that you get from basically a NSX site. You'll download it and basically send it up to your your VMware environment. And when you install that, you can start provisioning out all of these components, right? So with the manager, there comes controllers, right? So there's the controller piece to all of those functions, which will distribute things, and we'll talk about some of those things here in a little bit. But it's basically your logical switching, your logical routing, your edge services gateway that we don't have on here, some things with load balancing, VPNs, and firewalls. So what are the prerequisites? So if you wanted to put this in your environment now, you need at least vCenter server and hypervisor running 5.5. It's at least. You can do it with 5.1. There's a lot of things and a lot of workarounds you have to do. You have to have multicast running in your environment to actually use 5.1. So really the best way to go is to use 5.5 if you're doing it at all, not even really from the IPv6 perspective. Your virtual distributed switch, right? So all hosts have to be part of a virtual distributed switch. So if you're kind of one of those holdovers that like using the static switches from VMware, or you like using Cisco's virtual switch or an open vSwitch or things like that, you're not going to be able to use this. And then the VDS itself has to be running on 5.5. And so another key component, and the things that really get your network operators and network administrators really confused, is now you have to change MTUs. You actually start to go up into the jumbo world for your interfaces. So all your uplinks on your VDSs that go to your physical switches have to at least be at 1550, but most people kind of recommend let's just take it up to 1600. So you have at least a 1600 MTU. So 50 bytes are dedicated specifically for VXLAN, and that goes whether you're using NSX or whether you're using Neutron or any of that stuff. Anytime you look at NFV, you're going to have to increase your MTU. That's just one of those prerequisites on the physical side. So how it works, right? So that VMware NSX manager that I said that you kind of upload that and you kind of provision out that OVF for the manager, you start actually from that point on, and we're going to go in this in a little demo, you're going to actually provision out some NSX controllers, and you can provision 2, 3, 5, as many as you want, distributing them across your clustered environment. You configure your VXLAN tunnel interfaces, your distributed firewall, and your edge services gateway. These are all the components that kind of build out a part of that. So your edge services gateway are the things that's going to do things like all your routing. There is some firewalling in there. You can actually distribute your provision a logical router, things that you can't do with IPv6 that I'll talk about here in a second. And basically the NSX controller basically installs all the virtual networking on all the ESX hosts. And this is an important distinction that you have to know about NSX, is that all of the virtual networking is all kernel modules on all your ESX hosts. So unlike some of the other NFV solutions that are out there, it is a little bit different here in that the networking is all the way down to the ESX host. So the kernel itself is doing the networking there, vice having a virtual machine actually doing networking across your enterprise. So, not sure how well you can see this, but basically, vSphere web client, you can kind of see that, right? So you provision out you install your NSX manager, and from that point on, you have, the aspect of provisioning out controllers. So you can see I have 2 controllers that are provisioned out here. You can have as many as you need, right? So just for a demo environment, I didn't provision too many controllers. So after you do that, right, so now you have VXLAN tunnel interfaces that you have to create, and those tools then deploy your logical virtual switches, your routers, your firewalls, your virtual load balancers, VPN services, things like that. And you end up with something that looks similar to this. Now this is, if you're looking at it from NSX, and this is virtual, right, so this little cloud, meaning this is all a virtual world, this is your physical layer 2 switch, and you're connecting and uplinking your VMware VDS switch. Behind that is usually an edge services gateway. Now it's like a VM, and you can distribute that VM throughout your enterprise. And underneath that, you have a logical virtual router that's actually distributed across all your ESX hosts. And underneath that, a virtual logical switch, and then your firewalling, which is interesting from the standpoint of your firewall administrators, especially if you're looking at solutions like this, because all the NFV solutions look at it from this standpoint, is that firewalls go all the way down to your individual VMs, right? No more is a situation where you have to go, this firewall is sitting way up in here, and I've got VRFs that are routing all my things to keep my traffic separated and secure. You can actually take this VM on one host, the same VM, and you can segregate traffic per tenant on the same ESX host, because you have that firewall sitting right in front of the network interface of the VM. So the capabilities, right, and I talked about that. So this thing right here, we talked about that edge services gateway, fully supports IPv6. Now this edge services gateway is a virtual machine, so it would be similar to how Viata has one virtual machine that runs as an NFV, kind of router edge services gateway. OpenStack, I think, uses it with their Neutron, things like that. And it can route all your traffic over those VXLAN tunnel interfaces. I'm going to talk about what limitations that is here in a little bit. But it's full support for IPv6 firewall creation. So your distributed firewall has full support. And it actually has a lot of interesting things when it goes into specific next header types, ICMPv6 types and codes. So it gets very interesting with at least the firewall rule creation. The routing, you're really limited on static routing. So you don't get any kind of routing protocols. You don't get BGP. You don't get OSPF. You don't get ISIS. You get none of that, right? From the standpoint of IPv6. You basically get static routing. And then there's full supporting for IPv6 load balancing. So that's really the capabilities. Not a whole lot, and that's really what I wanted to say. This isn't ready for production, but this is definitely something to look at as things start moving on. Now, there's a lot of limitations, right? That first one here, your underlay network, and this is probably the situation that a lot of the NFV vendors are dealing with. That underlay network, their VXLAN network, is IPv4 only. So those tunnels that are created over VXLAN are all IPv4. So your individual hosts that are talking via VXLAN are all going over IPv4. Underneath that, of course, is your native IPv6. The logical virtual router has no IPv6 support. So if you wanted to provision a logical virtual router that has more distributed functions than an ESG would have, it has no support for that right now for v6. So you can't even type an IPv6 address in there without it erroring out on you. And this is one of the things that came from Nicira, right? So you had VMware kind of created out an edge services gateway, and Nicira had all the logical switching, the VXLAN, all that stuff that came with it. No support for routing or addressing at all. And your ESG has no support for any kind of routing protocols. None of the ones you can think of. And the one that kind of disturbed me a little bit is the edge services gateway doesn't do anything with router advertisements. From what I can see from the standpoint, there's no DHCPv6 relay, there's no DHCPv6 server. There isn't a whole lot of neighbor discovery communication either. So if you're going to do a capture, and I can come and show you some of the captures and some of the VMs that are sitting behind those, is there's not a whole lot actually going on. And that's good from the standpoint if you're doing provisioning and things like that, and you want to statically provision things, but if you wanted to have some more of an automated provisioning for IP pools and things like that, you wouldn't be able to do that necessarily. So let's talk about how we deploy it, right? So the kind of first thing we do is we're creating that IPv6 enabled LAN, VXLAN tunnel interface. From that point onto the logical virtual switch, we make sure that subnet is now tied to that edge services gateway. So in the edge services gateway, I'll show you how that links in to the virtual switch. And you're attaching that VTI now to the virtual machine. You're configuring your firewall rules. Now, in the firewall, it says you can allow all, or kind of accept all, permit all, or you can, allow only by exception, things like that. And then you configure the IPv6 address on the VM. So something similar to this, and I don't want to go too much depth about how replication modes work, but with the switches, for the logical virtual switches, there's a replication that happens, right? So they replicate MAC address tables across all of these nodes because, again, it's distributed, right? They can do it via either multicast, it can be done on unicast, or it can be done on some little hybrid. So in that you're doing it locally multicast, and then you're doing it unicast across a wide area network, or you're doing it only unicast and things like that. So on my edge services gateway now, I provision basically it's a pretty similar and pretty simple at least function there, right? So you're basically taking your uplink, configuring your uplink. So that's our little IPv6 address here and our IPv4 address, and then our VNIC1, which is basically our sub interface or our actual interface where our servers are sitting. So it's our server subnet, if you will. And then configuring a default route. You configure it there, just a static route. Again, these OSPF, BGP, ISIS, that's all for IPv4. Again, not for IPv6. And then configuring again basically my route for my /60 with all my server subnets that are behind that. I'd have to configure a static route pointing at that uplink interface for the NSX or the ESG. Make sense? And then now I want to actually tie a virtual machine. It's not as similar as how you do it, say, from the standpoint of I've got all my virtual machines and I want to select a NIC, right? You want to go in the edge services gateway then, and you can script this, of course, and it'll be provisioning, but if you're doing it from the vCenter side, you really want to kind of go in and actually add the machines to the switch that have that pseudo wire that's associated with that. So I go in there and I add those in there. And again, I had to actually add specifically static addresses, netmask, and a gateway. And you see this isn't a link local gateway either. This is a globally unicast gateway. So as far as being a router from the standpoint of being an IPv6 router that has a lot of functions for router advertisement, things like that, that doesn't exist right now. And that's basically a static input in there. And from that point, I can get to Google and I can get to everything else because it's encapsulating me then over VXLAN. So from the standpoint of IPv6 and how NSX works, we took out, basically from the standpoint is you don't see a logical virtual router in there anymore. You basically have your virtual machines, and they connect to a virtual firewall. Those virtual firewalls, again, distributed across ESX hosts with those rules that follow them as they move to ESX hosts. And my logical virtual switch that, again, follows me. It moves my virtual machines beyond. and then attaches to an edge services gateway, which doesn't necessarily move. It can move, of course, with Affinity rules, or if things that you're moving around across your enterprise. However, they are virtual machines, and you have to remember that. And then that gateway, of course, layer 2 uplinks through the VDS, and then connects the VDS uplinks to the physical switch, and I have a 3750G that's sitting up there. So basically a trunk port, the tagged VLAN being the VLAN 90, but thinking from the standpoint is, even with IPv4, is that there's one VLAN, right? So your network administrators now are thinking, okay, so how many subnets do you have? You basically have one VLAN. And IPv4, I actually have it routing over OSPF, so it actually advertises subnets and things like that. But it's one VLAN, right? So you can provision thousands of subnets beyond here, with just that one VLAN on the layer 2 side up front. Make sense? All right, so I'm going to kind of show you here. Let's hope the demo gods have answered our prayers and seen that everything's going okay. Looks like we're good. All right. So, if you're familiar, right? So, VMware stopped supporting their little client application, so now they're pretty much using their web interface for their vSphere stuff. So, as you can see in here, I have my installation. When I upload that virtual machine for the NSX Manager, now I have to install these components. So I come in here and actually install the NSX Manager, and then I come in here and we'll actually install controllers. So you can actually install more than one controller. Again, they have to be a part of the same data center, or at least on different data centers, a part of the same cluster pool. So that all goes in here. It doesn't necessarily need to be in shared storage, so like things like NAS or NFS, but it is kind of recommended that you have your controllers on some shared storage in case you have any kind of host outages, things like that. When you do this, it takes about 30 minutes to install a controller, and I don't know why. I mean, there's a lot of churn that it takes to do that, so just to be wary when you're doing that. And then you come in here and then you actually install your logical switches, right? So we have our one logical switch here, and we have, look at this here. Actually, let me go back to the installation here real quick. So I have when we do the installation, right, we have to actually do host preparation. And this is where this comes down to where it actually pushes down all those network functions to the kernels of the individual ESX hosts. So as you can see in my little cluster that I have here, it's got all the hosts that are part of that. And they've been installed, right? So they have, their VXLAN, all of their networking and everything installed associated with that. And then I basically go in here and I create my VXLAN transports. And as you can see, right, do not unconfigure that. So as you can see here, I have inside of my cluster, I have the hosts that are a part of that. VLAN that's tagged on the outside of that, and of course you can see my MTU here being 1600, right? So just make sure you're matching your MTU across from your VXLAN tunnel interface to your VDS or your virtual distributed switch up to your physical switch. And then I go into, again, those switches, right? So I configured a switch, and I have it. It's running in unicast mode. I made it just for unicast for reasons of simplicity here. And then I go into my NSX Edge, and this is where it all gets into this is where all the IPv6 magic happens from NSX side. As you can go in there, and it's a pretty powerful virtual machine. You have their basic settings that are associated with that. And then I have my interfaces, right? So kind of what I showed you before, kind of hard to see on the screen. But I got my addresses associated with that. It has the standpoint of doing IPv4 DHCP, but again, doesn't have, IPv6 DHCPv6. I can do NATing for IPv4, but then I can also do routing for IPv4. So as you can see with OSPF, I have an OSPF area created to my uplink router for IPv4. Again, I don't have it for IPv6. And it's basically it's just basically a basic static route that's associated with that, as you can see here. And then there's a load balancer, right? So it's a pretty interesting basic load balancer, right? So you have standpoint of doing things like least connections, round robin, and all that kind of stuff that you can do with your pools that are associated with it. So in this example, right, I have two virtual machines. One is, and they're both running Linux, and they have an Apache web server. And I have basically them a part of the pool here. And what you can do is basically you can add those members of the pool, and so you don't necessarily need to type an IP address in there. So you basically take your virtual machine, throw it in there, and it'll do both IPv4 and IPv6. That's a good little function of that, so I don't have to put all that in there. And it does the health checking, right? So you can do monitors for just basic TCP or HTTP or HTTPS, things like that. What's that? I'm sorry, I didn't hear the question. Oh, this is all part of NSX. So this is the Edge Services Gateway. So everything that comes here is all part of the Edge Services Gateway. So that all comes with NSX.
Firewall application aware?
What's that?
Firewall application aware, like Palo Alto?
No, I mean, so I know VMware's plans right now are to pull in Palo Alto, so you can actually buy another Palo Alto virtual machine to be a part of this. And they're actually, I think, looking at plans to put Palo Alto as a kernel module in here as well. But this firewall is your basic port protocol stateful firewall. So it's not really application aware. It doesn't do kind of like web application firewall stuff or any of that other stuff. But like I said, basic firewall. So to kind of go back to that, let's talk about the firewall here for a second here. So I didn't talk about that here, right? So I've got some basic firewall rules that I have set up. And we have right here. So on one of my machines right now, I'm just doing a ping. I'll show you how it's, running along my ping here. And I'll go in here and actually change the rule itself and actually have it blocked. Here. So you basically have the option of doing allow, block, reject, log, things like that. And it'll log it to like a syslog server and things like that. Publish those changes and those get pushed out. And while it's getting pushed out, you can see my ping starts to drop. Makes sense? So basic firewalling, right? So you can kind of see some of those firewalls that are in here. So let me set this back here real quick to allow. But one of the things I did want to show you, though, is that some of these firewall rules actually can be pretty interesting as far as the amount of types and codes and things like that from the IPv6 side that you don't necessarily have here. Oop. Oh, my bad. Wrong one here. Service. So I can look for different types of services that are out there. Basic stuff here. You can actually do a filter on IPv6 and you can see some of the stuff that's associated with it, right? So I've got my basic stuff right here. I've got MLD that can be a part of that. Path view discovery if I need to allow it, stuff like that. And then all your TCP, UDP, and all that other stuff that's associated with it. So going back to that, right? So we have our kind of load balancer that we had set up here. I'm having problems, I guess, seeing the top here. Okay. Give me a second here. I'll pull up another browser. So you can see I just basically have like a, basic default web page that I have set up on those two servers. And it's basically doing least connections, so you can see it changing up here to web server 1, web server 2, things like that. It's done, so. That's basically it. So from the standpoint of production, I just wanted to reiterate, right? And I'll show you here back to the PowerPoint here, is that it's not, it's not 100% ready for production, right? So you basically have what you have right now, on a basic sense. You don't really have kind of that. So any questions? Yes.
So for things like application monitoring, I've struggled with how to get at that, I guess, east-west traffic and get that into analyzers and things like that. Have you had to work on that, or any comments surrounding?
So from the VMware side, I know they have a lot of stuff where you can do NetFlow from the virtual distributed switch. They also have that function built in with some of their virtual switches as well. So you do have that. Is that kind of what you're referring to?
Well, when NetFlow is not enough, and you need to see deeper into the packet and collect that, I'm a NetScout shop.
Yeah, you can always run a tap, just like Gigamon's whole thing, yeah.
Gotcha.
Use the microphone, please.
What's that?
He's offering a suggestion.
Okay.
I just recommended using Gigamon when you're running the hypervisor. Then it can get all that traffic and offload it to whatever monitoring or management systems you need for them.
No, it's a great suggestion. Absolutely. And then basically anything that can tap into your virtual environment can be a part of this NSX world, right? So this whole network function virtualization can be a part of that. So.
My question is on management, because you have compute, network, storage, everything converging in these environments. And you're a network guy, obviously, that knows virtualization. But in a lot of organizations, that's not the case. Network guys that need to do this stuff don't know anything about NSX and probably never even heard of it and VMware. So I've experienced problems just even having guys manage Nexus 1000V environments and stuff like that. So do you have any recommendations on how to bridge that gap? You have a network team, virtual team. Do you make a third team, or do you teach the virtualization guys network stuff? Do you teach the network guys virtualization stuff?
So
just curious.
It's kind of a little bit of both, right? So it's kind of a little bit of both. I've had that same issue in dealing with virtualization engineers and network engineers, right? So you'll have some that are going to be motivated to learn this because they know they're not going to be sitting on a CLI in 10 years. If they think they're going to be like that in 10 years, they're going to be like with the rest of the telecom engineers that were running T1s. They don't work there anymore. You see what I'm saying? So these guys know that if they, you just have to say, network engineers, you got to learn your VMware world. But struggling with that demarcation point of who controls what part of the network gets interesting. But a lot of things like provisioning tools, like orchestration tools, actually kind of help that in that nobody touches anything anymore, right? You get an email saying you've got this VLAN that needs to be provisioned. Are you going to approve it? Yes, no. And then it goes through a workflow at that point and auto provisions it, right? So everything's script generated from this point on. So from that standpoint, right, both the network and the virtualization side, so the virtualization guys are used to dealing with vCenter, right? So they need to stop dealing with vCenter as these kind of orchestration tools get built in, right? So it's just from both sides of the world, they're looking at and struggling with that and how that's going to go forward. Does that answer your question, though? Kind of a weird question to answer, but yeah. I got you.
I'm curious if you have best practice, or what's worked, what hasn't.
It's really on the individual, right? The individual network engineer or the individual seeing how motivated they are to learn new things, right? Yeah. Good?
So quick question on standard NSX deployments with the VTEP, right? You're going to offload your exterior gateway routing configuration to that. Is there any v6 support that you've seen for any of the providers with the VTEP and silicon to be able to offload for performance on getting NSX back out in a routing domain, right? Versus the ESG, right?
Oh, so from VMware side, their logical virtual router doesn't have support for it.
Right. So you need a VTEP in order to be able to.
Right.
Is there anything in terms of restrictions, or have you had a chance to sort of look at what's being supported or not being supported there?
So from the standpoint of VMware side, or from
standpoint of the hardware side for
hardware side.
Yeah.
Oh, okay. No, I haven't really had a chance to really dig into the performance on that one at all.
Okay. I was just sort of curious because it becomes a performance problem once you hit a certain size of distributed workload. And then what have you seen going across clusters? Have you seen any problems with actually getting multiple ESXi hosts for neighbor discovery for anything that's going on that's multicast related?
Yeah, so that's the thing. It's like you're going to have that problem. So if you need to depend on that stuff, it's almost like if it has to be east-west communication,
So north-south, you're going to be okay.
You're going to be okay. East-west, there's going to be a lot of, they can talk to each other. There is neighbor solicitation that does happen on the VM side. So that traffic does there.
Is it on box? Is it only on box on the same ESXi host, or is it on spanning across?
No, it's spanning across. So it is distributing those neighbor discovery packets. So it is doing that. So you do see that stuff on the layer 2 side.
Okay.
How well it's doing it, if it's doing it well, I would, like I said, I do not think this is ready for production yet. And I'm dealing with VMware right now, and I know a lot of other folks are saying these are what things you need to do when you implement this stuff, just like Chip's working with the folks at the OpenStack. I mean, it requires us to go back in there and kind of help forklift some of the problems they had when building out the Nicera deployment. So,
right.
But yeah, from neighbor discovery, I still see that stuff happening. The router doesn't do any of it. That's the problem.
Right. So. Okay. And then the underlay, you say no v6 support at all, not roadmapped. Is that a structural problem with ESXi? Because I know ESXi has had some difficulties on some of the v6 support.
I really think it is a structural problem when it comes to that. They won't tell me specifically if it is, but there is no plans, at least I see in the future, of actually making that change.
Yeah, because 6 has had some improvements on the v6 support for ESXi, but it's been, that was a long, hard-fought battle that Christian and others had to sort of fight internally to make that happen. Okay.
It's not strictly an IPv6 question, but do you know anything about sort of the internals as far as how hardware resources are allocated to these virtual network devices? Because intellectually, as a networking person, I want 100% of the CPU of the entire cluster devoted to moving these packets. And once they have been delivered, then the VMs can have some CPU to try to process them. And I'm guessing that's not what's going on.
No, it's not.
But it's not really very transparent.
It isn't. It isn't. You're not seeing a lot of that stuff, especially how it's allocated. Resourcing is done by a data center. You building out a data center, you can allocate CPU provisioning, memory, storage, all that other stuff. They don't have that capability yet to say, make it a higher priority for network traffic to use the CPU to do these things. So that's why I said in a really highly scaled environment, that's most likely a production environment. This is not there yet. So I don't recommend it. Now, if it's something you want to try out in a lab, absolutely. See if you can break it. You can probably break it pretty easily. But, yeah, I couldn't answer your question. Sorry. Yep.
But you can still make Affinity for a core. So you would still get CPU cycles dedicated off that vCPU for that particular instance.
Right.
So as long as you're doing provisioning that way, you should be okay. Right? You're not oversubscribed on your vCPU. You can still have an Affinity 141 depending on how many sockets and how many actual cores you have on that socket. As long as you don't over-provision, you're guaranteed you're going to get one to multipath for threading for that particular offload. And then if you have SRIOV, you should be able to offload that way too, right?
Yeah.
So it should be able to take advantage of all those. Should. As long as you map it together, right?
Should. Anybody else? Yeah.
I stepped out for a minute. Did anybody ask if the firewalling is stateful in any way? Was that already asked? Or?
I mean, it is stateful. It's not application aware, right? So the basic firewalling is, right, it'll manage a state for a TCP session.
Okay.
But that's about it, right? It doesn't go any further than that, right? So it's a basic firewall, your basic port protocol firewall. And someone else asked that earlier, but Palo Alto has a module that you can build in there. And in fact, in the next, I don't know, I think it may be later this year, that Palo Alto firewall is actually going to be a kernel module now, so you can actually install it to do that. And it is application aware. Now, how well it does with v6, I've had some issues with Palo Alto and v6 before, so.
Great. Just one last question. Would it support NAT, the firewall?
Right. It does support NAT for IPv4, not for v6 though, which is a good thing, I guess. Okay, thanks.
Might as well get your camera.
So it's going to be an announcement for an upcoming event. Okay, just a quick announcement we're going to do in the next 5 minutes. And also we're going to give away a lot of books here in a minute. So thank you.
Hey, good morning, afternoon, everybody. Almost afternoon. I'm Curtis Kali'ia'a, a senior network engineer with Sandia National Laboratories. I've asked to make a comment and inform the IPv6 community of an area that, from my perspective at a national laboratory, we see a lot of work happening, and that's in the 16 Department of Homeland Security critical infrastructure sectors. So why is that important to the IPv6 community? It's because the United States government, states, tribes, and particularly the private sector are all partners in critical infrastructure protection and resilience, which is an important area in my work. What does that mean to the IPv6 community? What we're seeing is a growing dependency on information communication technologies across the board. And we're right at that pivot point, as we know, from legacy to next gen, or IPv4 to IPv6. So all of that growth that's emerging, for example, in energy sector with smart grid, is going to need to happen with IPv6. A couple of immediate areas that are impacting critical infrastructure sectors, particularly with IPv6, is IT is its own critical infrastructure sector. Communications is its own critical infrastructure sector. Emergency services, so that is also dependent on our RF communications and IP communications. So just in that whole area of critical infrastructures, of communications, energy, all of those areas are tremendous areas of opportunity for the IPv6 community to be aware of as technology progresses, as smart grid, smart home, all of those things progress. So thanks to everyone here at the IPv6 conference to allow me to speak for a moment. And I'd like to also thank you for your great work in bringing the leadership forward.